All right, 5.4. Factor and solve polynomial equations.
Okay.
Factor?
I'll do the sledding.
Why you go up? It's not actually as hard as it looks.
No, it's harder.
Oh, gosh.
But am I wrong?
All right, so this next part is going to kind of be review, something you've seen before, but always good to have a refresher.
Oh,
Tell us how you really feel, David.
no.
I said, tell us how you really feel. All right, so if it is a general trinomial, something like 2x squared minus 3x minus 20 is equal to 2x plus 5 times x minus 4. What?
Nothing.
Peyton was like, have we done this before? And I was like, well, she did say the first part was
So that's just a general factoring. You just make a factor tree, factor that out. Next one is a special type. It's perfect square trinomial. Which would be something like x squared plus 8x plus 16, which factors into x plus 4 squared. Next one, another special type, a difference of squares. That would be something like 9x squared minus 1, which factors into 3x plus 1 and 3x minus 1. And then the last one would be a common monomial factor. It's 8x squared plus 20x, which would take out a 4x from both pieces. It'd be 4x times 2x plus 5. So now we have a definition. A factorable polynomial with integer coefficients is factored completely. Okay, so that's what we're defining. If it is written as the product of unfactorable polynomials with integer coefficients. So something like 2 times x plus 1 times x minus 4 is factored completely. But x squared minus 4 is not factored completely. Because it can be broken down into x plus 2 and x minus 2. So none of that's really new. You already kind of know that. So we're going to get into the new thing that we have. Purple. All right, special factoring patterns. All right, so we have the sum of two cubes so this is if you have a cubed plus b cubed. This factors into a plus b times a squared minus ab plus b squared. Okay, and basically you just have to memorize that formula. That's the sum of two cubes. We also have the difference of two cubes. So if I have a cubed minus b cubed, this factors into a minus b times a squared plus ab plus b squared. And you're probably looking at the signs and thinking, what in the world? Like, why are they that way? How are they determining what they are? Blah, blah, blah. Well, that's where soap comes in handy. We always need our soap. This stands for same, opposite, always positive. So, what that means, first sign is always the same sign that you started with. Second sign is opposite. So whatever the opposite sign is from what you started with. The last sign is always positive. So same sign, opposite sign, always positive. This was courtesy of Logan that graduated last year. Something one of his teachers had told him. I had never heard it before, but it makes it way easier to remember. So the same sign, it matches. This one's the opposite sign. And then the last one's always positive. So if you can remember the letters, because those are the same, all you have to remember is soap. I say all like it's not kind of a lot to remember, but it does make it easier.
Explain it again. Sorry.
Okay, same sign. So whatever the sign you start with, the first parentheses is always going to be the same sign. The second sign is going to be the opposite. So if you started with positive, it's going to be negative. If you start with negative, it's going to be positive. And then the last one is always positive. And then the very last thing that should also basically be a review is factor by grouping. Don't die on me, Josh.
No, it's just a daily. Yeah.
Come in.
I don't know.
A lot.
What was that?
So.
Yeah, you missed a lot. Okay, you missed it.
You just missed the most unfortunate new thing in the lesson.
Yeah.
It's very,
Thanks.
very complicated. It
Yeah.
takes years to get.
RA plus RB plus SA plus SB.
You weren't ready for it.
I wasn't prepared.
We're factoring something out of both, like whatever they have in common. So I'm going to factor out an R from the first one. And then have A plus B left. I can take an S out of the second one. So that's plus S times A plus B is what was left over. So then because these are the same, the A plus B's match, I can do R plus S times A plus B. And you factored by grouping, which you do this naturally anyways when you factor with like a normal factor tree. All right, I think that's all the notes. Let me check. Yes, all the notes. We just have to, there's a long section, holy cow. to examples.